Hello. If you want to get a job at a big tech company, you need strong data structures and algorithm skills. But knowing DSA alone isn't enough. You also need to clearly structure your thoughts and communicate your reasoning to the interviewer. That's why, in this video, I'll run a mock interview based on the very first LeetCode problem TwoSum. This way, you'll not only understand the problem and its solution, but also learn how to explain it confidently during an interview. Let's get started. Hi there, thanks for joining us today. We'll start with a coding task. Are you ready?
Hi, yes, I'm ready.
Okay, great. The problem is saying that you're given an array of integers nums and an integer target. You need to return the indices of the two numbers such that they add up to the target.
Okay, let me quickly note down the requirements to make sure I understood the problem completely. We have input, which can be nums, which is array of integers. For example, let's say 2, 7, and 11. And we have the target, which is a single integer, let's say 11, let's say 9. And as for the output, I need to return an array of two indices that point to the numbers summing up to that target. So in this example, it would be an array of 0 and 1 because those are the positions of 2 and 7. Let me write down. Okay, 0 and 1.
Yes, you got it right.
Okay, thinking about the data itself, if I have an array like 3, 2, and 4, and the target is 6, I see that 2 plus 4 gives me the result, but I could also technically use 3 plus 3, and the output will be 0 and 0. Is it possible to use the same element twice, or should I always look for two distinct elements?
You must use two distinct indices.
Okay, understood. And what if I am given an array where no such pair exists, for example, like this? Should I return an empty list, or can I assume that a solution always be present?
You can assume that exactly one solution will always exist.
Perfect. That simplifies things. One last check on the constraints. How large can the input get?
The array can have up to 10,000 elements.
Thinking about how to solve this, the most initiative way would be a brute force approach. I just use nested loops to compare every single pair of numbers. But as we discussed, with up to 10,000 elements, that would give us an O(n squared time complexity. In the worst case, that's like 100 million operations, which is definitely not ideal.
Right, O(n squared is probably going to be a bottleneck. Do you have any ideas how to optimize that?
Uh, Probably we can look for the complement. For example, if my current number is x, I'm basically searching the rest of the array for target minus x. In this example, it would be 7. So yeah, and instead of scanning the array every time, we can use a hash map to give us all of one lookups. The plan is to do a single pass for each number. I'll check if its complement is already in the map, and if it is, we found the pair. If not, I'll just remember the current number by adding it to the map.
And how would you evaluate the complexity of this new approach?
Well, since we only iterate through the list once and hash map operations are constant time, the time complexity drops to O of n, linear time, and for space complexity, it'll be O of n as well, because in the worst case scenario, we might end up storing almost every element in the map before finding a match. I think for most production systems, this is a much better balance.
I agree, often is much better. Let's see how you would implement that.
So I'll start by defining the function itself. Let's call it TwoSum. Inputs are nums and target. And let's initialize an empty dictionary called privmap. This is where we'll keep track of the values we've already seen and their corresponding indices. Now I'll iterate through the nums array using enumerate because I need both the index and the actual value of each element. And inside the loop, the first thing I'll do is calculate the diff or the complement, which is target minus our current number n. And so now I just need to check if this diff is already in my priv map. And if it is, that means we found our two numbers. So I'll return the index of the complement and the current index. Let's write it. So if diff in priv map, then I return an array of priv map with the value of diff with its index and current index. And if we haven't found the complement yet, I'll simply add the current number n to the priv map with its index, so we can check it against future numbers in the iteration. And since the problem guarantees that one solution always exists, the code will always return from within that loop. Let's take nums equals 2, 7, and 11 and the target of 9. First we have 2. The diff is 9 minus 2, which is 7. And looking at our map, it's currently empty, so we skip if block and just add 2 to the map. Now priv map stores 2 at index 0. Next element is 7. The diff here is 2, and we check if 2 already is in the map. It is, so we return, I have a mistake here. So we return two indices of priv map by diff, which will be 2, yeah, and it's index 0, and current index, which is 1, so we get 0 and 1, which is exactly what we expected.
Perfect. That's a great solution, but let's imagine a follow-up scenario. Suppose we're very constrained on memory and we cannot afford open space. Is there another way to solve this, perhaps by changing the input?
That's an interesting constraint. If we must achieve all of one space, let me think for a second. Probably we could sort the array first, and once the array is sorted, we can use the two pointers technique. We place one pointer at the very beginning and another at the end. We calculate their sum, and if the sum is too small, we move the left pointer forward to increase it, and if the sum is too large compared to target, we move the right pointer backward to decrease it.
And what would be the complexity in that case?
The time complexity would be dominated by sorting, which is O of n log n, and the space complexity would be O of 1 or O of log n, depending on the sorting implementation's recursion stack. So it's a trade-off. We save memory, but we lose some speed compared to the previous hash map approach.
Exactly. Thanks for highlighting that. I have no further questions. Great job on both the algorithm and the communication today.
Thank you. It was a pleasure.